All right, here we go. Let's take a look at some differential equations that would appear on the AP exams. Now, this one's from the 2018 AP exam. There's my differential equation. It's an equation with a derivative in it. This is question number 6. So it was the last question on the exam, and there's no calculator allowed. Now, the first part is the slope field, which is basically kind of like a derivative field or a magnetic field. We haven't done these. Don't worry about these. We don't need to do these. We're going to go straight on with question B, which is a particular solution to a given differential equation. Okay, so let's get started. Here's where we start. We know that dy by dx, it's not just a function of x. It's 1/3 x bracket y minus 2 squared. So the derivative is a function of both x and y, which is kind of weird. Okay, it says we're going to use the initial condition f of 1 is equal to 0. It says write an equation for the tangent line at x equal to 1. So in other words, they want to know the y equals mx plus b. So hang on, the slope depends upon both x and y. So in other words, the slope, y prime, right? This is the slope is going to be plug in x and y. 1/3, when the x value is 1, the y value equals 0. X value is 1, y value is 0 minus 2 squared. So this is going to be 1/3 times 4, which is 4/3. There we go. So we know that the slope is 4/3, and we know that the x and y values are 1 and 0. So I could either go y equals mx plus b, or remember this one, y equals y1 is equal to the slope x minus x1. I could do that. That's probably fast. So the y value is 0. So y minus 0 is equal to the slope, 4/3, bracket x minus the x value, which is 1. X minus 1. There's my slope. Or sorry, there's my tangent line equation. Now it says use an equation for the line tangent to the graph at f of x equal to 1 to approximate f of 0.7. Oh, this is a tangent line approximation. F of 0.7 is equal to... Okay, hang on. So remember this? F of the x value is approximately equal to f prime of the close value times x minus the close plus f of the close value. Oh yeah, that was a tangent line approximation because I know the slope. Here we go. The slope. So if the x value is 0.7, the close value is 1, right? That's close. So this is going to be f prime of 1. And then it's 1 minus, oh sorry, it's the x value. The x value is actually 0.7, isn't it? Let's try that. 0.7 minus 1 plus f of the close value, f of 1. Or in other words, this is approximately equal to the slope, which is 4/3, times 0.7, this is negative 0.3 or negative 3/10, in other words, plus f of 1, when the x value is 1, y value is 0. So in other words, this is 3's canceled, so it's negative 4/10. In other words, it's negative 2/5 or negative 0.4. Okay, so that's the first part. Now let's do C. C is where we're actually solving the differential equation. Now in the differential equation, here we go. dy by dx is equal to x over 3 y minus 2 squared. I want to separate this. I want to separate the left and the right, and it says find a particular solution with f of 1 is equal to 0. So y is going to go over here, x is going to, okay, so hang on. dx is going to multiply out. This is x over 3 dx. This divides down to the bottom. So in other words, it's 1 over, but in other words, it's y minus 2 to the negative 2 dy. This looks weird because I've got my differentials. I recognize it when it's got, there we go, integral symbols. I can integrate this. I know this is, well, it's x to the 1, so it becomes 1/3 times, this is x squared over 2 plus c. And over here, this is like saying 1 over y to, okay, y to the negative 2, I can do the power rule. So increase it by 1 becomes y to the negative 1. Then I'm going to divide by negative 1, so negative. The reason I can do that is because the derivative of the inside is just 1. Right? If this was a different function, I'd have to think about dividing by the derivative, but no. Quickly do the derivative of this. Hang on, let's do the derivative. This comes down, becomes positive, y minus 2 to the negative 2 times 1. Yes, there we go. We're good. So this is kind of ugly. Let's clean this up. This is really negative 1 over y minus 2. This is x squared over 6 plus a constant, right? Now, I can either simplify this stuff, or you know what? I could plug in Remember, it was 1 comma 0. When the x value is 1, the y value is 0. Let's do that right now. Because look, this becomes 0 minus 2. So this becomes negative 1 over negative. This becomes a half. The x value is 1. This is 1/6 plus c. So in other words, 1/2, or in other words, 3/6 is 1/6 plus c. C is 2/6, or in other words, c is a third. But hang on, I haven't finished. I need to actually go back and solve for y equals. So this was the stage we had here. Let's simplify this. Negative 1 over y minus 2 is equal to x squared over 6 plus 1/3. You know what? Let's make that 2/6 right now, just to make my life easier. So in other words, negative 1 over y minus 2 is x squared plus 2 all over 6. Hang on. Y minus 2 over negative 1 is 6 over x squared plus 2. I'm just doing the reciprocals of both sides. Okay, take this and multiply it up. Y minus 2 is negative 6 all over x squared plus 2. Here we go. Y is equal to, add on the 2. 2 minus 6 all over x squared plus 2. There we go. That's what y is equal to. In the question, it specifically said solve for y equals, so they want us to actually solve y equals. Otherwise, if it was really ugly, sometimes we'd leave it in this form back here, but there it is. Okay, let's try one more. How about 2014 exam? The 2014 exam. Once again, this one starts off with the slope field. We're not going to do the slope field, not to worry about it. But here's my differential equation. dy by dx is 3 minus y cos x. So it's a function of both y's and x's. They want it to be a particular solution at f of 0 is 1. Okay. So b, it says write an equation for the tangent line. Use the equation to approximate this. And then they want to... This would probably be a good one to do. Okay, so let's give this one a shot. Here we go. I've got... So this is 2014 exam. I know that dy by dx is 3 minus y times cos x. Now, it says at the point 0, 1, right, they want us to figure out the line tangent. So I know that the slope is going to be at 0, 1, right? When the x value is 0, the y value is 1. So this becomes 3 minus 1 times cos of 0. Remember, cos of 0 is actually equal to 1. So this is 2 times, so the slope becomes 2. There we go. So I could go to this one. I could go to y equals mx plus b, because I know the slope is 2. X plus b, y. I don't know what b is, but you know what? If you plug in your x and y values right now, I know that 1 is equal to 2 times 0 plus b. That means b is 1. So here we go. Y is equal to 2x plus 1. There's my slope of the tangent line. So they want us to use that to approximate. What's f of 0.2? I don't know. Remember, this is an approximation. Approximation's a big concept in calculus. So f of x is approximately equal to f of c, x minus c, f prime of c plus f of c. So f of 0.2 is approximately equal to f prime of 0, 0.2 minus 0, plus f of 0. The derivative at 0 turned out to be 2. Come on, work. This is 0.2, and f of 0 was 1. So this is 0.2 plus, this is approximately 1.4. That's a good approximation for f of 0.2. Okay, so now the next part, we're actually going to solve the differential equation. This is where you get lost your marks. This one's worth 5 marks, I believe. Okay, so hang on. So dy by dx is 3 minus y cos x. Separate. Y is over here, x is over there. So the 3 minus y's go on to the bottom. So I'm going to get into the, well, hang on. Before we do the integral, it's going to be dy over 3 minus y, because I can move that around as one term. x multiplies up. This is cos x dx. Looks kind of weird without the integral symbol, so let's put them in. Let's integrate both sides. Integral of cos x is sine, or is it negative sine? Hang on. Sine x? Think about it. Do the derivative. The derivative of sine is cos. Done. Yes. And so this is like saying 1 over. Oh yeah, this is a logarithm. So this is ln of 3 minus y. Is it? Hang on. If I quickly did the derivative of ln, I'd get 1 over 3 minus y times negative 1. Oh, so it needs to be negative. Hang on, let's try that. The derivative of ln 3 minus y is 1 over 3 minus y times negative 1. Negative, negative cancels, positive. Good. Let's get rid of this negative right now. Ln 3 minus y is equal to negative sine x. Now, should I say minus c or plus c? Well, it doesn't really matter. I know it's just some constant, but at this stage now, I should probably start plugging in my my value. So I'm going to sub in 0, 1. When the x value is 0, sine of 0, 0, this becomes 1. So ln of the absolute value of 3 minus 1. Yeah, that's also known as 2. This is negative sine of 0, which is 0, plus c. So in other words, ln 2 is equal to c. Okay, so that's a number. It's an actual constant. Okay, so let's go back to maybe here, this stage here. And let's actually see if we can solve for y equals. So ln of 3 minus y is equal to ln 2. So it's ln 2 minus sine of c. Get rid of that. Minus sine of x. There we go. Let's do this. Let's get rid of that. That'll cancel. So this becomes 3 minus y. This is e to the power of ln 2 minus sine x. Hang on, I remember this. When you have two different parts of the exponents, it's as if this was e to the ln 2 times e to the negative sine x. Yes, I could have done that as division, but I'd rather not. This is just 2. This is the number 2. E to the power of ln, those cancel. This becomes the number 2. This is e to the negative sine x, which is not going to get any prettier. This is 3 minus y. Great. I'm going to move the y over, and I'm going to move this stuff over. So here we go. 3 minus 2e to the negative sine x is equal to y. There's my solution.